ॐ भूर्भुवस्सुवः तत्सवितुर्वरेण्यं भर्गो देवस्य धीमहि धियो यो नः प्रचोदयात्. Hello friends, welcome to my channel. Today we are going to discuss the brief syllabus overview of basic electronic engineering or analog electronics or device physics or electronic devices and circuits part 2. This part is also called as linear integrated circuits or linear IC applications. First of all, we will learn the basic introduction to linear integrated circuits and integrated circuits. Sorry, not linear integrated circuits. What are the advantages of integrated circuits, classification of integrated circuits, and the level of integration. Then we will move on to linear integrated circuits, which is our operational amplifier. What is the symbol of operational amplifier? How many terminals will be for an operational amplifier? What are the different packages available? What is the pin diagram and what is the power supply connection? Then we will see identification and ordering of operational amplifier. Then we will move on to ideal characteristics of operational amplifier, which are our infinite open loop gain, infinite input impedance, zero output impedance, infinite bandwidth, infinite slew rate, and zero offset. Then we will move on to what are the assumptions of an operational amplifier. Then we will move on to what are the equivalent circuit block diagram. Then we will see the inverting amplifier, from which we can get the inverter, and what is a non-inverting amplifier and what is a differential amplifier. Then we will see some applications, linear and non-linear applications. Linear applications of operational amplifier will be voltage follower, subtractor, adder subtractor, summer, V2I converter, I2V converter, instrumentation amplifier, analog computation, and power amplifier. Subtractor can be obtained from differential amplifier. Adder and subtractor can also be obtained from differential amplifier. And summer or summing amplifier can be again classified into inverting summing amplifier and non-inverting summing amplifier. From summing amplifier we can get the summer or adder. Then voltage to current converter is again can be done using grounded load method or floating load. Then we will see I2V converter, instrumentation amplifier, analog computation, and power amplifiers. Then we will see what are the nonlinear applications of operational amplifier. The nonlinear applications of operational amplifier will be rectifiers, peak detector, clipper, clamper, sample and hold circuit, log and anti-log amplifier, multiplier, divider, integrator, differentiator, and comparator. First of all, we should know what is meant by a precision diode. Using precision diode only we can do full wave rectifier, half wave rectifier, peak detector, positive clamper, positive clipper, negative clipper. Precision diode is the basic for the clippers, clampers, peak detector and rectifier. Then we will see the working of sample and hold circuit, what is meant by a sampling theorem. Then we will see what is log and anti-log amplifier. Then we will see multiplier and its applications like frequency doubler, square circuit, phase angle detector. Then we will see what is meant by a divider and its application square root waveform, square root circuit. Then we will see what is an ideal and a practical integrator, what is a differentiator, then comparator. Comparator is again classified into non-inverting comparator and inverting comparator. We will see some of the applications of comparator like zero crossing detector or square wave form generator and window detector, time maker generator, phase meter or phase angle detector. Then we will see what is meant by a Smith triggerer or regenerative comparator. Then we will see what is the triangular waveform generator. Then we will move on to DC characteristics of operational amplifier, where we will see input bias current, input offset current, input offset voltage, thermal drift. Thermal drift again we will see change in temperature, change in supply voltage, change in time. and their compensations. Then we will see what are the AC characteristics of operational amplifier, which are slew rate and frequency response. Then we will see common mode rejection ratio CMRR. Then we will see what are the signal generators, that is Wein bridge oscillator and RC phase shift oscillator. Then we will move on to regulators. What is a regulator? What is meant by a regulated power supply? What are the different blocks of regulated power supply, that is series pass transistor. Then we will see the classification, that is a series regulator and switching regulator. We will see what is meant by a series regulator, fixed 3-terminal positive voltage regulator, that is 78XX, and fixed 3-terminal negative voltage regulator 79XX. And then we will see what are the characteristics of 3-terminal regulator. Then we will see some terms like line regulation, load regulation, ripple rejection. Then we will see what is the 723 general purpose regulator, for which we will learn what is the pin diagram or schematic diagram and functional block diagram. How can we use 723 general purpose regulator for low voltage power supply? We will see the schematic or pin diagram, functional block diagram. And how can we use 723 general purpose regulator for high voltage power supply? We will see the schematic or pin diagram, functional block diagram. Then we will move on to data converters. Data converters, block diagram and classification. Data converters classified into analog to digital converter and digital to analog converter. We will see analog to digital converter, where we will see the functional diagram and we will see different types, that is direct type and indirect type. Again, in direct type we have flash or parallel comparator type and counter type, tracking or servo type, successive approximation. In indirect we have charge balancing and dual slope. Then we will see what are the performance parameters of analog to digital converters, that is resolution, accuracy, monotonicity, conversion time, settling time, stability and linearity. Then we will see what is meant by digital to analog converter, the block diagram and the different types. We have R to 2R ladder, inverted R to 2R ladder. We will see that. Then we will see what is meant by 555 timer. What is the use of timer? For maintaining a proper time delay, we will use 555 timer. Then we will see what is the pin or schematic diagram of 555 timer and what is the functional block diagram of 555 timer. Then we will see monostable operation of 555 timer, where we will see again schematic or pin diagram of monostable 555 timer and a functional block diagram of monostable 555 timer. We also see the applications of monostable mode of operation for a 555 timer. Those are frequency divider, phase width modulator, missing pulse detector, linear ramp generator. Then we will see a stable mode operation. Again we will see a stable mode operation of 555 timer, schematic or pin diagram, a stable mode 555 timer, functional block diagram and a stable mode applications. The applications will be pulse position modulator, square generator, FSK generator. What is meant by FSK? We will see. FSK is frequency shift keying. Then we will see phase locked loops. What is the block diagram of phase locked loops? What are the different things involved in phase locked loops? And then we will see what is meant by free running frequency, what is meant by capture range, what is meant by lock-in range, what is meant by track-in range. And the first part of this block diagram will be your phase detector. We will see different types of phase detectors, like analog phase detector, in which we will get only half wave, hence it is called as half wave phase detector. And we will see how to get a full wave phase detector. Then we will see digital phase detector, where we can do using XOR gate or edge triggered. Then we will see what is voltage control oscillator VCO, which generates the free running frequency F0, its pin diagram and functional diagram. Then we will see what are the different filters and applications of phase locked loops will be frequency multiplication, frequency division, frequency translation or synthesizer, AM detection, that is AM modulation or demodulation, FM detection, that is FM modulation or demodulation, and FSK demodulation, that is frequency shift keying demodulation. With this, your linear integrated circuits will be over. Thank you for watching my video. For more videos, do share, subscribe, like and comment. With this, the brief introduction or the brief syllabus overview of analog electronics or electronic devices and circuits or device physics or basic electronics engineering or linear integrated circuits, linear IC applications is over. In next video, we will start our sessions with the semiconductor theory, which plays the major basic role for this subject. Thank you. Okay friends, for more educational videos, do subscribe our channel, AR Educational channel. Share, like and comment friends. We need your support. We need your support which motivate us to do more videos further. For learning basic concepts and test your knowledge and to give suggestions and also to clear your conceptual doubts, follow us on our Instagram account. Thank you friends for watching our video.